Thank you very much. Thanks, Kevin, for the introduction. Just checking, can you see my screen?
Yeah, we can see your screen.
Yeah. Okay, cool. So I'm joining from Australia. You probably you recognize the shape of this map. You might have not seen this particular map that shows the indigenous languages across Australia. And before I start my talk, I would like to say that I'm joining from Boonwurrung country. So that's the blue dot. And the red dot corresponds to Woiwurrung country, where RMIT University and my office is. So today I'm joining from home, therefore Boonwurrung country. And I would like to start by acknowledging country. I would like to acknowledge the people of Woiwurrung and Boonwurrung language groups of the Eastern Kulin Nations, on whose stolen lands I live, teach, work, and learn. I acknowledge that sovereignty was never ceded, and I respectfully acknowledge their ancestors and elders, past, present, and emerging. And I pay my respects to traditional custodians and ancestors of the lands and waters across Australia, and to any Aboriginal and Torres Strait Islander people that might be joining us today or watch the video of this talk. So what I'm going to talk about today is a workshop paper presented at the bias workshop at ECIR this year, and this is the work that Binjile did during his master's, and is a collaboration with my colleague Professor Scholler and Hui Xia from the Melbourne Law School, where we started thinking about algorithmic bias and trying to think of methodologies that we could use to better understand black box systems such as search engines. So you might agree with me that search engines have shaped the way we access information nowadays, and we consume information online. And one of the way we access information, we submit a query and we get a search engine results page. And something that it is not trivial to understand is what's going on with the algorithm behind the scenes, no, and how search engines provide the search results when we issue a query. And then, so one question that you might ask is what are the methodologies that we could use to make sense of how the algorithm works and search engines works, in particular if you are not an expert in information retrieval or web search. So then the idea of this work was, okay, can we use crowdsourcing as a methodology to open that black box? And we mainly look at in the context of COVID-related searches. We look at one research question was to think, well, if we have different users, do different users get the same search results when they submit a particular query? And the other aspect that we look at is, well, if we have the same user, but we reformulate or formulate the intent in a very subtle, different phrasing of that intent in the keywords, in the query with different keywords, would we get the same search results or not? So for instance, here I have an example where I have, should I get vaccinated for COVID? And what happens if we negate that question and we say, should I avoid getting vaccinated for COVID? So in this type of queries that might be important to give genuine and correct information about about the impact of effectiveness of vaccines and in terms of related to COVID. So you might argue that, well, so if someone comes with a different have heard about, or for a particular you read a blog that is telling you, or you watch a TikTok video telling you that you shouldn't getting vaccinated, that you might phrase your query in that way, but that shouldn't impact the information or the correct information that the search engine would need to present. So then the second research question was looking at if results vary between positive and negative query formulations. So how we did, what did we do? So basically, we look at crowdsourcing. So in this forum, this might be straightforward because we are all familiar, but basically in a crowdsourcing platform, we have requesters that publish microtasks or human intelligent tasks, HITs, and those are annotations. So generally, we use it for obtaining some of the annotations that Kevin was talking about, like labels in particular for training and evaluating machine learning, different machine learning systems. And crowd workers can choose to carry out a micro task at their convenience. So in this particular work, we use the platform, crowdsourcing platform, Amazon Mechanical Turk. And here is a snapshot of what the crowd workers sees when they accept the micro tasks. So basically, being presented like has a web app where what we ask crowd workers is to upload the HTML that they seen when we ask them to submit a particular query, and we have 10 queries that are prefixed, and we ask them to submit those queries and give and upload the HTML that they receive from their search engine. So basically, they need to do three steps. So one is they submit the query to a commercial web search engine. In this case, was Google using their browser. They download the search engine result page that they obtain from that submitting that query as an HTML file, and then they upload the HTML file into the web app that I just presented. And then the web app removes all the personal information. For instance, if they are logged in, it removes the information about their account or email address before saving the HTML. And they do that for all of those queries that we have predefined. So in particular, we have 10 queries, all related to health related, and in particular related to COVID. So we have, and they are, as you can see in the screen, so they are grouped in 5 pairs. So each pair has a positive and a negative formulation of the kind of same query. And we use different ways of negating. So the first two, they use not as negation, but then we have avoid or effective or ineffective. And the idea was to see, like, for instance, we might think that terms such as not, so might be used as stop words in the preprocessing of the query preprocessing of the search engine. And the assumption, our hypothesis is, well, we don't think we are going to obtain two different search results. So what we had was 10 queries per hit. We ran a pilot, a preliminary study that I'm presenting today with 50 participants. And we only had one incorrect submission, so we accepted 50, and in total we had out of 51. And we also asked participants who are workers with a pre-questionnaire about demographics, age, gender, country of origin, country of residence, level of education. And in the graph, I'm showing the distribution of country of residence across the participants, most of them from United States, but also India and Brazil, and a few outliers from other countries such as Germany and Spain. So how can we compare? Now we got search engine result page for 50 crowd workers and for 10 queries grouped in pairs. So how can we compare different search engine result pages? So one way of doing that is using a metric designed by William Weber, Alistair Moffat, and Justin Zobel from University of Melbourne, called rank bias overlap, which is basically a way of comparing rankings when the items in the two rankings might not be from the same set. So you might have a ranking that is longer than the other one with a search result that are not in the other one, etc. So those are so it's a metric that considers that into account. And then this metric has a parameter P that is the probability of the user to continue inspecting the ranking, and you can use that to set what kind of like what is the strength of the weighting of the top ranks. So you can, for instance, if you set P to 0.66, the user inspects, you assume that the user will inspect only the top 3 search results. So it's a way of controlling the top weighting of the metric. Another way of comparing rankings is considering rankings as set of items, and then you can do compare using Jacquard similarity that looks at the overlap of item in 2 sets. This does not consider ranking positions, but measures conjointness. And in terms of granularity, we can do that in 2 levels. So either we consider the domain of the items in the rankings, or the actual URL, which is more granular. So some preliminary results. Do different users see different SERPs? So here in the x-axis, we have the participants, the crowd workers, and then the y-axis is rank bias overlap, and the box plot shows the distributions of the pairwise comparisons of the rankings for the queries. So as we can see, there is a pattern here that we can identify that is a country of residence. So workers that are from the same, from the most popular country of residence in our crowd workers are generally having higher rank bias overlap, whereas the workers that come from the other countries, they see they have more less similar, more dissimilar rankings. If we do that for the Jacquard similarity, we see the same pattern. To understand the second research questions, if we have different query formulations, if there are differences in the rankings that we obtain, we also see that there is some pattern there, no? So we can see that those that are from the same country as residents, so they share the similar rank bias overlap, and this is telling us that there is a factor of contextualization happening, no? So depending on where you are submitting those queries from, so you might see different search results. The other effect that is and at domain level, so we see at URL level, we see that overall the rank bias overlap scores are lower than we would expect, no? So there is something happening in terms of negation is having some effect here. If we compare at domain level, we see that the scores are higher, but still are lower than we would expect. No, so it's not this, the rankings are not completely similar, and the difference between, so when we go at domain level, we can see that the positive and negative formulations retrieve different URLs from similar domains for some of the query pairs. For instance, this is should I get vaccinated? Should I avoid getting vaccinated? But yeah, as I said, the rank bias overlap scores are far from being close to 1. We try to look at, so one question is, okay, so we see that there are some differences. Are those good or bad differences? No, so we don't know, because maybe having a negation is giving you a different search result, but is of the equal quality, no, of the one that you equivalent quality from the one that you would get if you were using a positive formulation. So we try to think of, okay, how can we measure the quality of information sources that the different SERPs have? So we try to estimate that by assuming, okay, so if we have search results that come from the governmental domain .gov, so those are more likely to be of reputable sources than others. And if we do that, we can see that also the so there are differences in terms of the positive and negative formulations, but this is very so the differences are not necessarily substantial. And again, the way of indicating quality of an information source might be arguable, no? So might be different. So not being from a governmental source doesn't necessarily mean that it's not of quality. So just to wrap up, we used a crowdsourcing platform to audit a web search engine using a set of queries related to COVID. We use Amazon Mechanical Turk and Google as a web search engine. This is obviously a preliminary study with only 50 crowd workers and 10 queries, but still we observe differences in the SERPs obtained by crowd workers. In terms of different users, the main difference was due to contextualization, so country of residence, but not necessarily other demographics. In terms of if the search results vary between positive and negative query formulations, surprisingly, yes, more than what we would have expected. But some formulations have more effect than others. So mainly the main take-home message from this preliminary experiment is that actually crowdsourcing is a valid approach to try to do this type of work in understanding black box systems, because crowd workers are keen to share what they see in a web search engine, for instance. And this is a more scalable but less controlled methodology than other approaches, such as data donation methodologies. So for instance, at the Center of Excellence, we had a project, the Australian Search Experience, where we ask volunteers to install a plugin, and then the plugin runs different queries behind the scenes to collect SERPs. And that is more controlled because you know who the actual donors are, but it's harder to scale because it's only based on volunteers that you can get access to. So crowdsourcing will give you more scalable methodology for that, which would be complementary to this one. for future work, needless to say, so larger query sets and larger number of workers. And that's it from me. So the paper is available, and the data that we collected from the crowdsourcing platform is also available on GitHub. Thank you very much.